Viewers, welcome to my YouTube channel, Mathematics Made Easy. So in today's video, we'll be looking into introduction to groups. Okay, so before we dive into the work, please don't forget to subscribe to my channel, like my videos, comment, and share. Thanks guys for watching. All right, guys, so let's get started. So firstly, I would like to define or to tell us what an algebraic structure is. So algebraic structure okay, so is a set of elements together with one or more operations that can be applied to those elements satisfying certain rules or properties. Are we together? So algebraic structure is a set of elements together with all more operations that can be applied to those elements satisfying certain rules or properties. Are we together? So we have examples of algebraic structures. So we have the groups, we have the rings, we have the field, and we have vector spaces. So those are the examples of the algebraic structures we have. But in today's video, we'll be looking into introduction to groups. Are we together? Now, let's get started to work. Groups. Now, firstly, I would like to define a group. So what is a group? A group is a non-empty set G together with a binary operation asterisk such that G takes from G then to G, where the operation A comma B is equal to AB. So satisfying the following axioms. That is, for G to be a group, it must satisfy some rules and some properties. Then we have four rules for an algebraic structure to be a group. Now, the first rule is the closure property. So, for an algebraic structure to be a group, the closure property must be satisfied, such that AB must be in G. Are we together? AB must be in G. That is, for all A, comma B in G. The second rule that must be satisfied is the associative property. That is, A into BC must be equal to AB into C. So for all A, comma B, comma C in G. The third rule that must be satisfied for an algebraic structure to be a group is that there must be an existence of the identity element. Okay, that is, there exists E in G. Okay, such that A multiplied by E will give us E A. That is, if A combined with E, we are going to have E A, and then this is going to give us A. That is for all A in G. That is, for an algebraic structure to be a group, there must exist there must be an existence of what? Of this identity element. That is, if you take the identity element and any other element in that set, we are going to have what? That element back. And that's what we did here. That is A combining with E. This will give us what? E combining with A, and this will give us A. So that property must also be satisfied for your algebraic structure to be a group. And the last property, for it to be a group, there must be the existence of what? Of inverse in the what? In the set. That is, for each element, okay, for each A in G, there exists B in G such that AB is equal to BA is equal to E. That is, B is equal to A inverse. Are we together? So that is, for each A in G, that is for each element in the group G, for each element in the set G, there exists B in G such that if you combine A and B together, it's going to give us the identity element. So where B will be the what? The inverse of A. So if these four properties are satisfied, then we said G, asterisk is a group. Now, we have a special property, which is the fifth property. The special property is the commutative property. So we say a group G is called a commutative property. A commutative or an abelian group So if the commutative property is satisfied, that is, if for all A, B in G, we have AB is equal to BA, then we said that algebraic structure is an abelian group or a commutative group. So that is that about the definition of a group and the properties that a group must satisfy. That is, the properties that an algebraic structure must satisfy for it to be a group. So in our next class, we are going to talk about some properties of a group. That is the basic concept of a group. Thanks guys for watching. Please don't forget to like, don't forget to comment, don't forget to share. See you next time. Goodbye.